In this video, we're going to talk about several functions that are important. They're kind of basic. We're going to build on them throughout the term. I'm going to refer to it as our library of functions. Okay? So this is kind of a list of functions. I would expect you to really know these forwards and backwards. Okay? Know them by name, know them by equation, know what their domain and their range is. We don't really find the range of all functions, but these functions in our library of functions will know the range of all of those. Okay, we're going to talk about 9 of them. There are really 10. I'll talk about the 10th one in class. It's a little bit different. Okay, so the first one is the constant function. So it is in the form for the equation of f of x is equal to some constant. So I graphed it where the constant was 2, but it would still be the same constant function if it were any other number. And basically, it's a horizontal line, right? So the domain of this is all real numbers, because x can be any number, but y is only whatever b is. So in this case, the whole range for this one would be 2. But whatever b is, that's your range. Okay, so this is the constant function. The second one is the identity function. So we call it the identity function because if you put x in, you get x back out. So when you put in 1, you get 1 out. When you put in 2, you get 2 out. When you put in -3, you get -3 out. Okay, that's the identity function. It's kind of our basic line. All lines then are kind of a shift on this and maybe tilted more. So this is kind of our basic standard line. The domain is all real numbers, and the range is all real numbers. The third one is the square function. Basically, it's our parabola. We've done quite a bit with this, I think, over your classes. It looks in the form of f of x equals x squared, and the domain is all real numbers, and the range is just all positive numbers, and 0. 0 is part of the range. We can get 0 as an answer. But the range goes from 0 to infinity. The cube function is x cubed. So f of x equals x cubed. That's the cube function. The domain on this is all real numbers. And the range is all real numbers because it goes forever in both directions. So we'll do the 4th power too as part of our power functions. And we could keep going and do the 5th power and however many, but they're all in the very same basic shapes. If it's an even powered, it's like the squared or the 4th power. It looks very much like the square function, doesn't it? It's a little flatter, that's all. So the domain is the same, it's all real numbers, and the range is from 0 to infinity. So those are the power functions. Now we'll look at the root functions. Okay, so first of all, the square root function. F of x equals the square root of x. Notice that it's kind of like half a parabola laying on its side. And as we go through this term, we'll see a lot more why that is like that. You notice that the domain, we talked about this in the domain video, is 0 to infinity. It can equal 0, right? You can take the square root of 0. But you can't take the square root of anything less, at least not and get a real number that we could graph, right? So we're dealing in the real numbers, so if it turns out to be imaginary, it really means it doesn't exist. The range is also only the positive numbers, because this symbol, remember when we learned about this in the previous classes, that symbol just means it's the positive one. And this is really kind of why we limit that to just the positive one, because otherwise it wouldn't be a function. So we have to limit it, or we wouldn't even have it as a function. So if I put 4 in for x, I get 2. I don't get negative 2, even though negative 2 times negative 2 is 4. The square root with the square root symbol means we only get the positive one. So the domain and the range are both from 0 to infinity. The cubed root. So this is cubed root of x, and it looks very much like the cube function, only kind of laying on its side, and there's a good reason for that. We'll talk about that later too. So the domain is all real numbers. It can go all the way up, it can go all the way down to negative infinity. So the domain is negative infinity to infinity. The range is also negative infinity to infinity. Even though it goes up a lot slower, it does eventually get there, right? It will eventually get to infinity all the way. It keeps going. It just goes a lot slower. All right, so those are our root functions. The fourth root is going to look very much like the square root. The fifth root is going to look very much like the cubed root. And so we're not going to really worry about them too much. All right, so now we have our reciprocal function. The reciprocal is 1 over x. And it's the same when we use reciprocal when we're talking about fractions and perpendicular slopes and stuff. It's the same reciprocal. It's 1 over the number that gives you the reciprocal. If I put in 2 for x, I'd get 1 over 2. If I put in 1/2 for x, I get 1 over 1/2, which is 2. So it just flips it upside down. So you can see that here, if I put in 1/2, I'd get 2. If I put in 1/4, I'd get 4. But I can never put in 0, because then I get 1 over 0. I can go all the way close. It can get infinitely close. So this is what we call an asymptote. You should have heard this before in your math classes, but it's a line that the function approaches, but it never actually crosses. And this actually has 2 asymptotes. It has a vertical asymptote at 0, and it has a horizontal asymptote at 0. And that's because the vertical one tells us the domain is from negative infinity to 0, and then 0 to infinity. The horizontal one tells us that the range is the same thing. Negative infinity to 0, 0 to infinity. Okay, that's the reciprocal function. Sometimes we talk about the reciprocal squared function. It would be 1 over x squared. I'm not going to require that you know that and keep track of all that information, but it wouldn't be that hard for you to figure that out. All right, the last one that we'll talk about in this video is the absolute value function. So we've been talking about the absolute value function, or we've been talking about absolute value equations, right? So as a function, this is what it looks like. It's this v, right? We're taking, if x is positive, we're just doing the identity function, right? So if we go from 0 up, this is just the identity function. If we look at 0 down, then we have the opposite of the identity function, a line with slope -1. Okay, so that's what we end up getting when we're looking at us as a function of x. And of course, we can plug anything in. We can plug anything into this absolute value. But what we get out, remember, is always a positive number. So our range goes from 0 to infinity. So always positive. Alright, so those are our 9 library of functions. There's one more that makes 10 called the greatest integer function, and not easy for me to graph on this program, and I think it would be easier for me to explain it to you in person. So we'll talk about that in class. And those 10 functions you will be responsible to know all about. I could ask you on a test, not tell you what it looks like, not tell you the equation, just say, tell me the domain of the reciprocal function, or tell me the domain of the cube function, and I would expect you to be able to know what that was and answer accordingly. Alright, so let me give you your quiz question. Here's your quiz question for 3.2c. Just give the domain of the reciprocal function in interval notation. Now, you and I both know that you can go back and look at that. Try to do it first. Try to think of what it would be and write it down without looking, and then go back and look and make sure everybody ought to get this one right.